All right, Algebra 1A students. Welcome to part 2 of lesson 4.6. In this video, we're still talking about functions, as we did in our last video. But in this video, we're talking about function notation and how that changes the way some of our equations are going to look at certain points of this course. It's basically an introduction to function notation, so I do need you to take some notes on that. So we've seen equations or functions represented involving x and y, like this one, y equals negative 3x plus 1. We've graphed a few of those in previous videos. We've made tables of values where we had x and y and things like that. Okay. Below is the same equation written using function notation. So what I want you to notice is that everything after the equal sign is 100% identical to what it is up here. Okay, negative 3x plus 1. It's exactly the same. The only thing that changed is that f of x has now replaced the letter y. It is read f of x. I know the parentheses throw you off a little bit, but that is what we say, f of x. Please also make sure that that gets somewhere in your notes, because I will expect you to be able to do that, to say that correctly, f of x. Okay? Now, f, the letter f is the name of the function. Okay? And you can use any letter you want for a function. You can use G, H, A, B, Z, P, Q, L, M, N, whatever you want. Okay? The letter f in this case is the name of a function. We usually use f just because it stands for function. Okay? Function notation here is used to emphasize that the function value depends on x, right? See how it says f of x? The x is the important part in function notation. Okay? Here's the main reason that I really like function notation. We can see the x and y value at the same time. Okay? And I'll show you what that means in just a second. But that's the key that I'd also like you to write down somewhere in your notes, that we can see the x and y value when we use function notation. Okay? So for example, here's a function here. It says the function w of x equals 250x, which is 250 times x, represents the number of words w of x you can read in x minutes. Okay, so w is for words, x is minutes. W of x says how many words in a certain number of minutes. Okay, so what they want to know is how many words can you read in 8 minutes. So what we should realize here is that x, in this case, is going to equal 8. Okay, x is going to equal 8. Which means, if I want to figure out what the w is, I just need to take that x value and put it in where my x variable is. But not only am I going to put it here with the 250, I'm also going to put it here in my function notation. Okay, so now what my function notation is going to say is w of 8 equals 250 times 8. Okay, so I've taken that x value and I've put it in for x. W of 8 equals 250 times 8. Okay, and what does that actually equal? 250 times 8, if we do that on our calculator, is 2,000. Okay, 2,000. So what we can say is w of 8 equals 2,000. W of 8 equals 2,000. Okay? The reason, like I said, that we like this is because not only can you see the y value, the number of words, but you can also see right now the number of minutes that are there, right? So we know that this is words. The 2,000 is the words. That's the w value. But here with the function notation, we can also see, well, how many minutes did we say this was taking us? 8 minutes, okay? So that's function notation. The equations are exactly the same. The process of evaluating them is exactly the same. But the notation that we use on one side of the equal sign is now different. Okay? That's just an introduction for you to a function notation, which you will see later on in this course. Okay. The other thing that I'm going to ask you to do with this function notation is to look at a certain function, in this case f of x equals negative 1.5x plus 4, and I'm going to give you values for the domain of that function. Remember, domain means x. Okay, just as a reminder, domain means x. And then they are going to want us to find the range of that function. And remember, range means y. What are the y values? What are the outputs? So what I have to do is take each x value in the domain that they give me, in this list of numbers, 1, 2, 3, 4, and plug them into x. Okay, I'm just going to keep plugging these in to x over and over and over again. All right. So the first one is going to say negative 1.5 times 1 plus 4. Second one's going to say negative 1.5 times 2 plus 4. Then negative 1.5 times 3 plus 4. And then negative 1.5 times 4 plus 4. Okay, together these are going to make my range values. All right, and if we do a little math here, negative 1.5 times 1 is just negative 1.5. Adding 4 to that will get us up to positive 2.5. Okay, so I know a positive 2.5 must be involved here somehow. Okay, so immediately I can go through and start eliminating some answers. Except I won't do that. Let's just keep going. Here, negative 1.5 times 2 is negative 3. Negative 3 plus 4 is a positive 1. Here, negative 1.5 times 3 is negative 4.5, plus 4 gives me a negative 0.5. And then down here, negative 1.5 times 4 is negative 6. Negative 6 plus 4 gives me a negative 2. So you can see these four numbers right here, 2.5, 1, negative 0.5, and negative 2, are my range, because those are the numbers that I got when I plugged in my domain numbers for x. Okay, and obviously that's this choice right here. Negative 2, negative 0.5, 1, and 2.5. Okay, that's my range. So I'd like you to try this yourself. Just a matter of plugging in a list of x numbers for your domain, and then finding the range and listing out those numbers for your range. Okay, so if the domain here of g of x equals 4x minus 12 is 1, 3, 5, 7, what is the range? So take a couple of minutes, pause the video, plug these numbers in there for x, get me a list of your range numbers, then come on back and I'll show you what we should have. All right, the range here should be negative 8, 0, positive 8, and positive 16. That's my range. Because when I put 1 in there, I get 4 minus 12, which is negative 8. 3 in there, I get 12 minus 12, which is 0. 5 in there, 20 minus 12 is 8. 7 in there, 28 minus 12 is 16. Okay? If you have questions about domain and range, finding the range given a certain list of domain numbers, or function notation, please make a note to ask me in class tomorrow. Otherwise, that's all I have for you. Have a wonderful night.